Okay, so thank you for coming back. We are on 5.5 Ready, Set, Go, and we're reviewing how to write inequalities from a word problem. In here, we're also going to talk about like maybe even switching the forms from like standard to maybe slope intercept. And then we're also going to talk about graphing. Okay, and we're going to talk about the advantages of all that. So um, that way, like, it's kind of a big review of a lot of things. So, on a final for a creative writing course, Ben was required to write a combination of at least 10 poems or paragraphs. Ben knew that each poem would take him 30 minutes to write, while a paragraph would only take him 10 minutes to write. Ben was given 2 hours to complete the exam. Write an inequality to model each constraint. Okay. So I'm going to read it again because then it helps you kind of like hear it. You shouldn't be reading word problems once and expecting yourself to write the like whatever. That's not a good way to go. So I'm going to read it again because the first time I just needed to know what was happening. Now I can go back and read it. And now that I know what's happening, I can pay attention to the little details. So on a final for a creative writing course, Ben was required to write a combination of at least 10 poems or paragraphs. So I'm going to highlight that. Ben, huh?
May I speak?
Yeah.
Okay, so from what I've learned, and be a little more hands-on, but from what I've learned, that we have to have 10 or more poems or paragraphs in a combination. So that's 10 is greater than or equal to.
So 10 is greater than or equal to like that?
Yeah, because we have to have 10 or more.
Good.
And then the information is the poem would take him 30 minutes to write, but a paragraph would only take him 10. And then Ben was only given 2 hours to complete the exam. So first, I think we should convert the time. So 2 hours, make it 120 minutes, just to have the same units. And this is where I kind of get a little lost.
Okay, so then I'm just going to read it again. I'm going to say that if you don't read your word problems at least 2 times, that's where you get stuck. So when you get stuck, just read it again. Okay. It's almost like knowing a story. Like it's almost like watching a movie. If you've ever watched a movie, you're like, oh, that's pretty cool. And then you watch the movie again. I can't do this with a lot of movies. Just flow with me on this one. When you watch it the second time, especially if it's a really intense movie, you start noticing details that for some reason you're like, wait, was I even paying attention at this part? Does that make sense? So that's what we want to do. We want to get so familiar with this word problem that we have all those little tiny details in front of us. Okay, so so it says on a final, Ben was required to write at least 10, and I agree with you. It has to be 10 is greater than or equal to. So he can write 11, he can write 12, he can write 13, and he'd be good, right? Ben knew that each poem takes him 30 minutes to write. So poems are 30 minutes. While a paragraph would only take him 10. Okay, and then lastly, Ben was given 2 hours to complete the exam. So sometimes what I like to do is I like to make a little table because there's all this information and I need to bring it all back together. Okay, so you guys already told me. So there's something with like time. So I'm going to write time. So you told me that there's a time constraint of 120 minutes. What other time constraints are there besides 120 minutes? And you can chat me if you want. Go ahead.
The differences are like 30 minutes for a poem and 10 minutes for a paragraph.
Okay, so I'm going to put 30 minutes and I'm going to put poem up here to organize my information. And you said a paragraph, and I'm just going to use the symbol because I don't want to write the whole thing out. And you said it was 10 minutes, right? So those are my time constraints, right? So you can start seeing, oh, do I have enough time to write all poems. And you're like, wait, 10 times 30 is 300. No, I can't. That's going to take way too long. Actually, not me, but Ben, right? That's going to take Ben way too long. Do I have enough time to write 10 10 paragraphs? And you're like, 10 times 10 is 100 minutes. Yeah, he has time to write 10 paragraphs. Okay, and then you can kind of see the combinations in between there, right? Okay, the other constraint is this. Yes. Do we have to make a combination? No, right now it just says to write an inequality. That's all it says right now. So I'm just going to focus on writing an inequality. So for each constraint. Okay, so that's the time one. And you can kind of see the inequality coming out there. But hold on, let's continue on. The other one is based on how many poems. So I'm just going to put number. Okay. So I have to do at least 10, right? And I don't know how many poems I'm going to write or Ben is going to write. So I'm going to put X. And I don't know how many paragraphs I'm going to write. So I'm going to write Y. So does everybody kind of see how we kind of already have our one of our constraints here? Can you write me a constraint for the rest of this? We already started with 10 has to be greater than or equal to what? Greater than or equal to what? Yeah, very good. So someone said X plus Y. Let's see if this makes sense. So the number of, let's see, sorry, my iPad's moving all over the place. The number of poems plus the number of paragraphs has to be less than or equal to 10. Is that right? Do we want it to be less than or equal to 10? And you guys are saying, okay, do you want 10 to be the most? Yeah, so we got to switch this guy around. So let's cross him out. So if you want to do it, you can go X plus Y is greater than equal to 10. And you guys are thinking, hey, Ms. Johnson, it's the same symbol. Yes, but I switched where X plus Y is, right? So this says X plus Y, the number of poems and paragraphs has to be more than 10, has to be at least 10. Okay. So that's one of them. Now, this one here, the second one for time, let's say I write one poem or two poems or three poems. How do you calculate how many minutes I'm spending? How do you calculate how many minutes you're spending? Yeah, go ahead.
You multiply the values of that inequality by 1 or by 2, by 3, how many you want.
Yes. So we're basically going to multiply 30 times x. So this is what one side is going to look like. It's going to look like 30x, right? And then you can imagine the rest. Can you practice writing the rest of it? Can you practice writing the rest of it? Don't worry about the symbol right now. Don't worry about greater than, less than. Who cares about that right now? Just write the next part. Write this, what I would write with y. Write that very next thing. Yeah, very good. Someone has it in the chat. Good job. Okay, so if you already have 10y, that's correct because that's how much time I'm going to spend on writing paragraphs. 10 times the number of paragraphs. That's what I was doing earlier. I said, do I have enough to write 10 poems? And you guys said yes, because it's 10 times 10, it's 100. Okay, and then we know that this other side is going to be 120. Okay. Now, do we want to spend more time than 120 or less time than 120?
Less time.
Yes. Why does it have to be less? Why does it have to be less? Well, because, just like in our class, right? I'm going to give you so much time. You can finish in a minute, right? I don't suggest that, but you can finish in a minute, but you can't go over our allotted time. Does that make sense? And in fact, in college, I've seen professors walk out And if you didn't give him your exam, you basically just got a 0. Okay. Sometimes they're not so kind. Okay, so there's my constraints. Okay. Okay. I'm going to show you how to graph from here. I'm going to show you how to graph from here. And then I'll show you how to switch it and solve for y. So the reason why I like graphing from here is I'm going to basically use the intercepts. Okay. So when I use intercepts, and I'm going to start with the easier equation, and then you guys are going to have to graph the harder one. So I'm going to graph the items graph. So I'm going to graph x plus y is greater than or equal to 10. Okay. So because I know that I'm not going to have any negatives, I'm going to pretend that this whole thing, this whole graph right here is the first quadrant. Okay, so I'm going to go like this. I'm going to go like this. And I'm going to say that this is, what did I say? X was poems. Okay, so this is poems. And this is paragraphs, right? So look at how I do this. So all I do is I basically plug in 0 for each of them. So I say, I make 2 little separate lines here. I say when x is equal to 0, I want to know what y is. So then I just plug in. So I go, and then I'm pretending that that greater than symbol is equal to. Yeah, it's the intercepts method. So I'm graphing intercepts. Okay. So then I plug in 0. So I get 0 plus y is equal to 10. I know you guys are like, Miss Johnson, but wait, why did you change it? Because I'm graphing, I just want to find the actual border, that borderline. Does that make sense? So then that means y equals to 10. So I'm going to graph this point, which is 0, 10. And so I go 0 and I go up 10. 2, 4, 6. This is so small. I can't do this. 2, 4, 6, 8, 10. So that's my point. Is everybody okay with that? Now I want you to switch it. Because I did x is equal to 0, I want you to say, what's x when y equals to 0? So plug that in. Give me a point down here. I'm going to give you a couple seconds to do that. And then when you have it, go ahead and tell me in the chat. So this is just a fast way to graph if they give it to you in standard form. Okay, this is a fast way to graph if they give it to you in standard form. All right, what did you guys get? Yes, you got 10, 0. Okay, so I'm going to plug this in. So I say x plus 0 is equal to 10. So therefore, x is equal to 10. So that means it's 10, 0. So go ahead and graph that on your graph right here. Two, 4, 6, 8, 10. So there's my line, okay? And I already know that my line, this is going to be solid, all right? So I'm going to do my best to graph a solid line here. Hey, that was pretty good. Look at me. Look at me. That's so fancy. Okay, then I have to figure out which side I'm shading. Am I shading up here or down here? I don't know. So what I always do is I choose 0, 0 as my plug-in checking point. And when I take 0, 0 and I check it in my inequality, I'm going to see if it's true. So here's me checking. Ready? 0 plus 0, is that greater than or equal to 10? Yes or no? 0 plus 0 is greater than 10. Is that true or false? Yeah, no. No. So that means this is not a solution. So that actually tells you about everybody on that side. Everybody over there, not a solution. So if that side is not a solution, where is my solution? Where is my solution?
The other side?
Yeah, which is where? Describe that.
Vaster on the graph.
Say above, below, behind, yeah, above. So you're just going to go above, and I do ask you to do this on the test. Describe where your solution set is. You're going to have to say above the line. So all those points are all solutions for this one constraint. Got it? Okay. Now I'm going to give you a second, and I want you to try this one. And I'm going to put it over here. Where'd it go? Here. So I want you to try the same thing. 30x plus 10y is less than or equal to 120. Okay, so go ahead and do that. Do the two sides. I'm going to pause the video, come back when you're done and ready to check it. Okay, so for this one, I'm just...
Could you do it a little slowly?
Yeah. So the very first thing that I'm going to do is I'm going to pretend that x... I'm not going to pretend. I'm going to say x is equal to 0, and I'm going to plug it in. So I'm really trying to find out what y is. So do that right now. Take your equation and plug in 0 when you see x. Plug in 0 when you see x. So you should have gotten 30 times 0 plus 10y less than or equal to 120, right? Well, 30 times 0 is 0. So then we get 10y is equal to, I'll write equal to 120. So that means y equals to 12. So some of you are combining your x and your y. Don't do that. So x is 0 and y is 12. Does that make sense? So here, x is 0, y is 12. So let me bring this in. So 2, 4, 6, 8, 10, 12. I think I did that right. 2, 8. Yeah, that looks right. So there's one of my points. Does that make sense? What questions do you have? What questions do you have? Okay, now I'm going to switch, right? I'm going to switch. I want to know what x is when y is 0. So now you write that equation for that. Yeah, exactly. Now solve it. You can say equal to. You can say equal to. Yeah, exactly. So now graph that. Very good. All right, here we go. Okay, sorry. I thought I was paused, but I wasn't. Okay, so now what I want to do is I'm going to plug it in again, and I'm going to go 30x plus 10 times 0 equals to 120. So 10 times 0 is 0, right? And so I get 30x equals to 120. So therefore, x has to be 4. So some of you are combining this x and this y. This is why I put a big old line here. Like they're not allowed to play together. These two numbers don't go together. How do I know that? Because the only way I got 12 for y was when I plugged in x as 0. So then my point is going to be 4 comma 0. So that goes here. And I'm going to do my best to draw a straight line. Again, this is a solid line. This tells me this is a solid line, not a dashed line, right? How did I check? How did I figure out which side I should shade? Who remembers that? How do I figure out which side I should shade? How did I figure that out? Very good. I plugged in this 0.00 and I checked to see if it works. So here's me checking. Let me check here. 0 plus 0 is less than or equal to 120. Is that true? Is 0 plus 0 less than or equal to 120?
Yes.
Yeah. So that means what? What does that mean? Now that it's equal to, okay, so what does that mean? This means yes. So what does that mean?
That means all other points in that area will work.
Good. So shade that side. So because this is true, we shade the 0, 0 side. Does that make sense? So that means all of these people down here, and just because it's not showing up in the graph, it actually is there. Does that make sense?
Yes.
Okay. So they didn't ask us to find the solution set, but because we're finished with the chapter, they were going through steps and steps. So I do want to show you what it actually looks like and check to see if we did a good job. Okay. So my equations were 30. Oh, I should put this other one because it's blue. X plus y is greater than or equal to 10. And 30x, I think, yeah, 30x, oops, that's not 30x, 30x plus 10y is less than or equal to 120. Okay, and so far you can only see the red one, right? So I'm going to squish it, and then now you see how they overlap. Pretend that I picked this up and I overlapped it here. Okay, so do you see what the solution set is? Where's the solution set here?
Where they intersect?
Yeah.
Where they meet.
Yeah. No. Okay. So some people are saying this wrong. So I want to make it sure. Some people are saying where they meet, not that point. The solution set is this section here where it's shaded both black and red. Both black and red. Does that make sense? So if I pick this up, which I can, if I picked this stuff up right here, which I'm not going to because I don't want to mess up my graph, but if I pick this up, move it and overlap it onto my other graph, it'd be the section that was shaded twice. So when I was watching some of your flip grids, that's where you all messed up. Some of you were saying, oh, the solution is right here, this point. No, the solution is all the points where the graph is shaded both red and black. Does that make sense? Both red and black.
Quick question.
Yeah.
Could we put that
Ms.
in?
Johnson?
Wait, hold on. So say it again.
Could we put that in as a valid answer for the test, like where's the solution set, all the points that are shaded so and so color on the Desmos graph that we put, and
Yeah.
pull up?
Just put that all the solution is where it's shaded twice. Okay.
I can write that on the test.
Yeah.
Okay, thank you.
Because if you say that it's this 0.1, 9, no, because 10, 0 is a solution. Whatever point that is right there, I think it's a 0, sorry, not 10, 0, but 0, 10 is a solution. 0, 11 is a solution. As weird as it sounds, according to this graph, it looks like 1.5, 9.5 is a solution. Even though in the context, 1.5 doesn't make sense, right? You can't write 1.5 poems. Can't do that. But according to this graph, it is. So according to this graph, my solutions look like it's, let's see, it's this point. So it's 1, 9. It's that point right there, which would be half. That doesn't work. So 0, 10. That point right there would be 0, 11. Those are your solutions. Everything else doesn't fit both constraints. Got it? Yeah. Uh-oh. You're really, really glitchy. Can you type your question in the chat, please? Okay. So while he's typing his question in the chat, I want to show you one thing. If I ask you to write the equation, if I give you a graph like this, do you see how much now easier it is to write it? When will this apply? I'm taking notes. The solution set, whenever we're graphing a system of inequalities. So it'll always look like, up here. This is my system of inequalities. Very good. So when I'm asking you to go backwards and I say, okay, I want you to graph, or I want you to find the solution, or I want you to I want you to write the equation of the inequalities graphed here. Okay, I ask you that at least 2 times on your test. So the way you would do this, first is you can steal the intercepts, right? So see how here you have intercepts. This intercept is 4, 0, and this intercept is 0, 12. And you can actually steal those, right? And write your inequality, right? So it's going to look like something like 4x plus 12y. And then you're going to figure out what number could that be, right? So in this case, you're like, but Miss Johnson, that one says 30x plus 10y. You're right. So then you have to figure out what it has to be less than or equal to, because this is a simplified version of it, right? Did I do that wrong? Is less than or equal to 48. Is that right? Wait, let me see. Hold on. Did I do that backwards? Hold on. Oh, when you write the equation, sorry. For easier for you guys, whenever you're writing the equation of an inequality, is probably going to be in slope-intercept form, right? So slope-intercept form for this one, why did that show back up? That's weird. There it goes. For this one is going to be my y-intercept. So looking at this pink graph, what's my y-intercept?
12.
Good. So it's going to be y.
0, 12.
Very good. Y equals mx plus b. What letter is 12? Is it?
Replace b with 12.
Very good. So this is 12 plus x stays, so does y. And now I just need to figure out the m. So the m in this case is going to be your slope. So because they gave me this other point, I could draw out my triangle. I'm going to go down this much and right this much, right? So I go down 12 and I go right 4, right? Sorry, everyone's coming in because of class. So give me 1 second, guys. So then my slope is going to be negative 12 over 4. Is everybody comfortable with negative 12 over 4? Slope is rise over run. Just don't forget your negatives. I think that's the biggest mistake people make. So there's your equation. Yes, you can simplify negative 12 over 4 to be negative 3 if you want, right? I'm going to honestly tell you, if you write negative 12 over 4, I'm giving you full credit. The only thing now we have to talk about is this greater than or less than? Now look here's my line, and all the points are shaded underneath the line. What would you assume, greater than or less than? What would you assume? Greater? Yeah, it's going to be less than. And then because we have the fact that it's a solid line, then we're going to put equal to. So it's easier to pull slope intercept off of a graph than it is to go back to this is called standard form over here. Okay, so with that being said, we reviewed a lot of stuff, right? We went over our equations, how to write them. We even organized our information in a chart. Some of you were like, wait, I don't get it. I'm going to suggest reading your problem over and over again. So much so that you can organize it into a little table like this. Because once we organized it like this into a table, correct me if I'm wrong, right? Like, didn't you see this pop out? Like, didn't these inequalities for the most part pop out? Yeah. So I'm going to say this again. The hardest part of this whole process, right, from here to here, is going to be when you had to write the inequalities, not graphing them, because you guys know how to graph and I let you use Desmos, right? It's not going to be figuring out if it's less than or greater than, because your mind will make logic out of it. Like as soon as we wrote 10 is greater than x plus y, I said, do you want 10 to be the most or at least? And you're like, oh no, this is wrong. We have to switch this. Said, well, Miss Johnson, switch it. And so we switch it. So that's not hard. The most difficult part that I saw you all struggle with today, right now, was just you writing these inequalities right here. And that came from your chart right here, right? Okay, so with that being said, let's see, how would you check your answer? I would plug in my answer. We wrote out a couple of the answers, and then I would go back to my word problem and check if Ben would still get a passing grade on his test based on some of the answers that we got. Okay, thanks for listening.